I'm Jiri Kuthan. I'm with Intuitive Labs, and I wish you, for the beginning, a very good morning. I know there are some of us who think that's an oxymoron, so I'll try to make a good morning at least better, if not good. And I'll start light, and I'll try to create a context between our today's work and what we have done like 20 years ago. And I noticed actually when Fred Posner was mentioning it's 20 years of Camaleo, I found myself a little bit older, no offense, I just didn't feel worse, but it's fact that we started this work, SIP router, or by then called SIP Express router, then later named to OpenSIPs, and Camaleo and OpenSer and what all the forks have been, had started 21 years ago. The planning began in 2000, and I tried to dig out some photographic proof of that. And I found a photo with a hidden message I'm going to show you right now. And what you see here is the SIP Express router, the open source software many have mentioned today under the name of Camaleo, installed on a handheld device, which was compact iPack. And this photo was taken in spring 2002, when we were participating, before publicly releasing a SIP Express router. We were participating in a SIP interoperability event in France, in an ETSI facility. And we were doing interoperability tests. And the interesting part was we were able to achieve 300 calls per second on this ARM processor handheld device. Now to the hidden message, which is a little bit mean too. On the right-hand side, you see our esteemed competitor. And interestingly, he was able to achieve the same performance, 300 calls per second. However, for that, because he was using a Java virtual machine, he needed a quad CPU sandbox, which is just putting in the transportation box. So I apologize, it's a little bit indecent, but this was, I hope that 20 years ago we can reveal some of the old-timer stories and show that by focus on performance, we were able to achieve quite a lot. And what it took by then was a lot of work on the SIP parser, because SIP parsing is very computationally expensive. It was a lot of concurrency work to make use of multiple CPUs. And it was also a lot of work on memory manager, because for SIP is very dynamic protocol by nature. So it means a lot of allocations of dynamic memory. It's actually the most frequent operation, and it really matters how well you do it. So that was 2002. We were really preoccupied with performance, and one of the reasons was we just like it. We despised the Java virtual machine and everything which was slow, and garbage collector, which was software which was supposed to be real-time unexpectedly. And I should also credit Andrei Palinescu, actually. He is one of the key authors who also wrote the first line, and he did a great deal of work on that. And the other motivation was security. And I think Fred Posner has mentioned that today, 2 days ago. If you want to have reasonable security, performance is a requirement. It's a must-have. You may have some blacklists, you can have whitelists, you can have some algorithms, but if your performance is lame and under overload, the thing collapses and doesn't recover when the overload is over, you can just forget it all. So that's why it's important that a SIP server runs even on a handheld device like iPack, because performance matters, and especially in the security context, it matters a lot. And I will now fast forward 20 years ahead and show why we think that this matters till today. So now from the a little bit financial point of view, the telecom damage caused by fraud and attacks is being estimated like $30 billion a year. It's not just voice over IP, that's all telecom. Voice over IP is a part of it, it's still growing. And I think it's a credible number. Because from the technical point of view, we have been researching. We know quite well that already as long as 10 years ago, there were the first botnet attacks targeting voice over IP infrastructure and being operated from like 1 million hosts. We know that when we start a AWS instance, it takes less than a till we begin to receive the first SIP scans. And if the SIP scans do find some service running there, we know that what's going to follow. And it's either attempts to make phone calls with different prefixes, or it's password guessing attacks, which show typically speed like 40 attempts per second. If you've got a naive password, which is listed in a famous dictionary, it will take less than an hour before the password is found. And that's real, that you can observe it every day. I'll show a little bit more on it later. And it's further a little bit complicated because SIP protocol is not easy. It has intermediaries, it has multiple parties, so sometimes it's a little bit difficult to find out if something is going wrong, where it's coming from. Sometimes it's a little bit not. We have had a NAT problem some 20 years ago, and one of the common solutions to that is to keep NAT bindings alive by sending a lot of registers. So, and that creates a lot of traffic, and you've got to separate real traffic from evil traffic from overhead traffic. Not easy in that quantity either. And there are some application layer or business layer nuances and gray zones which make also difficult to identify what's good and what's bad. And as an example, in Europe, if you come late from your office and open up TV, sometimes there are friendly ladies, and they are suggesting something like, "Hey, I'm Leila, call me." And if you call, I didn't believe that until I tried, but really, if you do and call a directory service and say, "I would like to call Leila," what happens is they don't ask about surname or anything else identifying the person. They just connect you, and Leila shows up as, "Hello, are you 18 years age or older?" And why some are doing that is apparently that on your company phone bill, a call to directory service appears, not to Leila. And these things happen, and they are sometimes difficult to differentiate if they are good, bad, if there shall be something done about them, or if it is a purpose, and so on and so forth. In all of the cases, however, what matters is time, because such fraud attacks can become extremely expensive very quickly. So it's time to respond that matters, and I will return to it a few times. Now, it's not like that we would have nothing today. We've got basically two methods, proactive and reactive. The proactive, I would say, mostly represented by session border controllers, firewalls, and static policies, which try to block things before they can do damage. And the most significant weakness is that you have to be smart enough to devise the policies so that nothing gets in that shall not. And that's not entirely easy. That's why we often have also some reactive methods, which, as good as the static policies are, they try to look, they assume Murphy's law, and when something has gone wrong, they try to find it out and help you to identify that. And there's also something in between, like penetration tests, which Sandro Gocci will be reporting on later today, which try to bridge those two. Well, we've got something else we would also like to try, and that's increase the automation in this process. Make sure that we identify threats, we detect them, and we adjust the policies, and all of that, of course, in real time, because time matters. Now, we roughly know what we need to do. We need to automate the detection and the update of policies and do it as close in real time. How to do that? Well, the state-of-the-art answer is we put it in cloud, and cloud will do everything for us, which I think it sounds a little bit too easy, but I think there is a big piece of truth in it. And that's because we think that with great focus and labor division, we can and a lot of data from customers, we can devise better policies in a cloud than your local admin can do. Nothing against the admin, but it's not an easy job. And also the cloud doesn't know of hours, where administrators do. So even if you have a very good voice over IP security administrator, a lot of the attacks happen on weekends. And when you come Monday morning in the office and you find your 200K bill for telephony, it's too late. So let's assume that cloud is a good answer. And of course, people begin to draft nice architectures, which will have a lot of things in common. You need to collect data to see what's wrong. You need to have some analytics, and you need to have some enforcement policies. And some actually are trying, you can see, and there are some differences in style. So for example, I would say there's a large category of SQL hats, which if it sees an evil packet, it sends it via SQL insert into a popular SQL database. There are some NoSQL hats who will be happy to wrap evil packets in JSON or YAML and store it somewhere. And there are some IP hats who are typically more lean. They encapsulate all traffic they see in some IP over IP or some other tunneling protocols, and so on and so forth. But we ask ourselves a few other questions. And that is, if you build such a monitoring system for security, how do you make sure, first of all, that the security system doesn't add to your resource consumption? If you're under DOS attack and all of your resources tend to be exhausted, are you going to send every single packet tunneled to some monitoring server? I would say not, because it will add to the load and it will actually support the attacker's objective of making your service unavailable. So you need to do something to be very, very lean, and you need to be cautious about not to over-report and not to over-monitor. The other thing is, how do you deal with trust? With telephony, you've got a lot of sensitive data. For example, we have been working with some government agencies, and they, like any other, need a lot of insights into how telephony signaling has been working, what have been the reasons why something has gone wrong. But they must never know, the administrators must never know who was calling whom. And it sounds like a difficult dilemma. You need to know everything to find errors, mistakes, security attacks. At the same time, you must not know who is calling whom. So, and even if you're not a government official and if you're not the German chancellor calling US president, you still may not be entirely interested in the word learning whom you have been calling. And if you pass sensitive data to the cloud and you don't encrypt them, I would say that's very much the same like publishing it on Facebook. Once the gin is out of the bottle, that's just not going to work. So we need to do something about privacy, confidentiality, and we need to assume zero trust, because you just cannot trust a cloud provider. It will be okay. And as said, if you do it lean way, if you do it in a way which preserves privacy, you still shall not forget the primary objective, which is offer rapid response to attacks. And there's a thing, I've got an announcement for you, because we are not just writing slides about that, we are writing. And the good thing is that we have been actually able to implement and release a SIP probe, which does exactly that. It collects SIP traffic and it generates events which describe what's been going on, and it does so in a lean way, which doesn't kill network traffic, which doesn't amplify DOS attacks, and it still keeps important information in events it generates. More than that, it actually does encrypt data it sends to a service. So even we, as cloud provider, have no idea who is calling whom. We get some encrypted data, good enough to do analytics with it, But if it was a call from your kid or if it was a call from US president, we have no idea to find out. Even if the security of the service is breached by an attack, the attackers will find nothing but encrypted data. And it's available right now with source code under a non-commercial use license. So that's here a little bit some numbers what I mean by lean, so that it's not just a yada yada talk. So as probably all of you know, a SIP call has quite many messages. If you get a SIP authenticated call, it's invite 407 acknowledgement, invite 100, 180, 200 acknowledgement again, and then it's going to be terminated by and to. That's alone like 10 messages. If you use the tunneling approach for monitoring, that's quite a lot. So we generate 2 events, that's 1 to 5. If you've got net keep alives, that they have to keep net bindings alive, and they typically expire within 1 minute. So if you do the tunneling approach again for monitoring, that means you generate 120 messages an hour. Well, we generate one which says someone has registered. We don't think that keep lives are worth reporting. DOS attack, same. You need to do something about that. We use exponential backoff algorithms. We absorb retransmissions and so on and so forth. In a nutshell, we use application-aware probe to significantly reduce resource consumption, which helps to not to amplify DOS attacks, which we want to find out, and not to amplify. Now, on the other thing, zero trust. Zero trust has been a notion used mostly along with access control. And assuming like everything has to be verified every time a request is resubmitted. We think it needs a little bit more today. And the reason is that server-side, if there is confidentiality promise, it is just a promise. And we want a guarantee. I mean, a promise is there to be broken. It's easily broken. If someone promises you, you give me your data, I will never reveal it, he may think so, but he may change his mind, or an employee of the company may change his mind, or the security of the site may be attacked and some third party may expose the data, or by some supply chain attacks, an error in someone else's software may reveal the sensitive data. So I think what we really want to do, and there are a couple of other reasons for privacy, I will skip that. There are some legislation reasons, company policy, and so on. But simply confidentiality is important, especially for calls. And that's why we think it's important not to rely on promises that get too easily broken. It's important to rely on guarantees. And that's why we encrypt the data. And I don't mean we encrypt data by putting everything on TLS, because it eventually arrives plain text in cloud, but we think it's important to encrypt data before it leaves the monitored premises. For your entertainment, there are a couple of questions which make it uneasy, like with SIP calls. What would you like to encrypt? You could certainly encrypt identities, URIs and IPs, and that makes sense, and that's what we certainly do. That's the who is calling whom. That's the most sensitive part. Sometimes it perhaps may not be enough. What if I'm the only guy who is using a Nokia SIP user agent in my company, and then revealing that a call has been made by the Nokia guy, show finger points at me. And there is other type of data like timestamps. If you encrypt that, it's great. Nobody knows anything, but sorting out data by encrypted timestamps would be quite a computational challenge. If anyone here in the room has an idea how to do that, please let me know. So we are trying to make a compromise what to encrypt and what not to encrypt. And still there are more challenges. If you've got encrypted data like identities, how do you search in them? How do you find the URIs you're looking for as the client, or as something as a system that raises alerts? Now you've got some management data challenges, like you've changed your password, or you've forgotten your password, or you're putting in a wrong password. And sometimes you may be getting garbage back, sometimes you may be losing your data. So there's a lot of corner cases which do not make it easy, but they are manageable. And eventually, if the data is well managed, the customer is able to retrieve the results, still encrypt it, and see the plain text in his browser or in some policy enforcement devices, firewalls, whatever. Now, I've got one more announcement to share. And in the beginning of it, there was a consideration that the probe is a cool, and I think it's really a nice piece of software because it can find things, put them in Elastic, and if you wish, you can download, try it out, and observe in Elastic, generate all kind of queries, see what it does. But it still belongs in the realm of reactive elements. It reports on what has happened in past. But we thought when we have it, we could actually a little bit turn the game, and we could find attackers before they find us. So what we have set up is a honeynet, which is also publicly available. It's based on the probe. The machines where the probes are running also have a Camellia on it, only serving in a role as sending negative messages back, not a big deal. But still, it's sitting there. And we have collected some, I think, 7,000 IP addresses since summer. It's running in 14 world regions, in APAC, in Europe, and in Americas. And as a bonus, when we thought, shall we export it via comma-separated values, or how are we going to share the results, we found out there was already very nice software called EpiBan, and there's a way for us to export the IP addresses we have found through Fred Posner's EpiBan interface. So that's available now. You can look at it. Over time, we will probably do more research and perhaps even provide some repositories which are showing why an IP address has been blacklisted and what's the context and so on and so forth. What we have seen so far is there are many scans. They use popular penetration tools like Sandro Gauchis, who will be maybe present after me. Some of them are, and some of them sincerely say, I'm a penetration tools. More often, however, they say, I'm Cisco, I'm Avaya Phone, I'm FPBX. We've got collected tens of those. They often come from the US. One would have perhaps been inclined to believe they come from China or other exotic places, but the majority of the scans does come from the US over a long period of over a month of time. And the other observation we have made is they are not based on some sophisticated attack patterns. We rarely see something which might be a distributed denial of service attacks. Most often what we see is either brute force dictionary guessing attacks or attempts just to make phone call at the number, which is probably some expensive premium number. And to achieve the goal, the attacker tries to send a phone call to that number with different prefixes. So you see he tries it the American way, 011, then he tries the European way, 00, and so on, one prefix after the other until he achieves the goal if the telephone number and prefix is not protected. And that's pretty much all I've had to share today. So let me wrap up. We think that the voice over IP security problems are there quite massively, and it's not like there would be nothing to deal with it today, but we think we can deal much better by improving the security know-how and very specifically by lowering the time to respond by way of automation. And we think cloud-based services can help greatly with that, as long as a couple of the design objective is met, and that is it comes with good data encryption because you do not want to reveal sensitive data to any cloud provider, as much as they can promise to. Probes are smart not to amplify loads. They have to identify and not to they have to identify and not to amplify denial of service attacks. And the whole system is good in combining the proactive and reactive policies in real time. And that's it.
Well, thank you very much, Jiri. A great on-time delivery. And if you're thinking that Jiri's friendly face looks somewhat familiar, not only has he been around the SIP world for a very long time, but he's also been a guest on ClueCon Weekly not that long ago. And ClueCon Weekly is something you can find on the Free Switch YouTube channel. Luca Pradavera's done a great job of interviewing various people at the moment. I interviewed Jiri a while ago. What questions do you have for Jiri based on his presentation or indeed his SIP history? Has anybody got any questions they would like to ask? I will check the online question repository and see that there are no online questions in this particular case, Jiri. It's turned into something of a European morning, because we've got Jiri now. We're going to have Sandro Gauci before too long. One last chance to ask Jiri. Oh, there you go. Moshe has stepped up to the plate. Go ahead, Moshe. You may need to press the button on the microphone.
Just a brief question. I was looking at the API ban website because it's very entertaining. I run fail to ban, so I have my own collection of bad actors. If I understand how API ban works correctly, then there's official honeypots, right? And I'm certain you don't want bad actors. Let's say I'm feeling in a bad mood and I decide to block him from using the telephony system. But is there any way to collect information from people like me, rather than relying on a collection of official honeypots?
Well, that's the challenge is how shall I trust you?
Absolutely. If Fred
Feeling is mutual, of course.
Yes, if Fred Posner were here in person, he'd say the same thing. You know, it's the community trust model that needs to be in place.
Right. I figured as much, but I thought I would double check to make sure I understood correctly. And I commend your work, because it's nice to have preemptive blocking rather than waiting for them to find me.
Thank you. So what we have seen with other reputation lists in the web area is that they often try to merge and reconcile the lists with each other, so that if an IP and they also are using some additional attributes which are associated with the IP address. So I think that's going to happen, that if there are more sources, you will try to identify the evil IP addresses with some reasons why it has been blacklisted. You compare it with the other lists in an automated way, and as a result, you will have quite credible assessment and a way to merge the data so that it's not just yours and someone else's too. I think that's going to happen inevitably.
Thank you, Jiri. And a question has flown in online, and it's from one Sandro Gauci. And he says, what you describe, Jiri, works pretty well for opportunistic attacks. Have you given much thought to targeted attacks where the attackers might not be scanning the internet, even the recent DDoS attacks?
So the probe, as we have it, is basically trying to report on SIP activities without asserting much about good or bad. We do that on the server side. But of course, if you generate some traffic which has some marks of being evil, and there are quite many today, then we will put you on a blacklist very quickly. Does it answer your question, or?
Well, I'll tell you what we'll do is we'll hand over to Sandro in a moment, and he can tell us whether it answered his question. In the meantime, let's give Jiri Kuthan a very big ClueCon thank you.